Something just got thrown out of our galaxy. Not drifting, not orbiting, ejected. Astronomers found an object moving so fast, more than 1.3 million miles per hour, that it's breaking free of the Milky Way forever.
In March 2026, the astrophysics community is focused on an anomaly that defies the standard mechanics of our neighborhood. A massive object, designated Quis J124909.08 plus 362116.0, or simply J1249 plus 36, has been detected moving at a blistering speed of roughly 1.3 million miles per hour. Unlike most stars that orbit the center of the Milky Way in a predictable, circular dance, J1249 plus 36 is on a hypervelocity trajectory. It isn't just moving fast, it is moving fast enough to break free from the Milky Way's gravitational grip entirely. As of early 2026, it is officially classified as a runaway, and the mystery of its ejection is forcing astronomers to reconsider the violent history of our galaxy's core. 1. The discovery, a citizen science breakthrough. The detection of J1249 plus 36 wasn't made by a multi-billion-dollar satellite alone, but by a group of citizen scientists participating in the Backyard Worlds Planet 9 project. While scanning data from NASA's Wide Field Infrared Survey Explorer, WISE, they spotted a faint, fast-moving object that didn't fit the profile of a standard star or a nearby planet. Follow-up observations in late 2025 using the W.M. Keck Observatory in Hawaii confirmed the impossible truth. The object is likely a low-mass star or a high-mass brown dwarf. It exists in the mass gap between the largest planets and the smallest stars, objects often called failed stars because they lack the mass to sustain hydrogen fusion in their cores. 2. The speed paradox, breaking the speed limit. To exit the Milky Way, an object must reach galactic escape velocity. For an object at J1249 plus 36's distance from the center, that speed is roughly 1 million miles per hour. This object is comfortably exceeding that limit. In the history of astronomy, we have found hypervelocity stars before, but they are almost always massive, bright blue giants. Finding a tiny, dim, failed star moving at these speeds is unprecedented. It is the cosmic equivalent of seeing a golf cart overtaking a Ferrari on the highway. 3. Theory A, the supernova slingshot. The leading hypothesis for why J1249 plus 36 is being kicked out involves a celestial murder-suicide known as a type I supernova. In this scenario, J1249 plus 36 was likely the companion to a white dwarf, the dense, dead core of a former star. The white dwarf acted as a cosmic vampire, siphoning gas away from J1249 plus 36 for millions of years. Eventually, the white dwarf accumulated so much mass that it became unstable and exploded in a catastrophic supernova. When the white dwarf vanished in a flash of light, the gravitational leash holding J1249 plus 36 was instantly cut. The sudden release sent the survivor flying into deep space at the same orbital speed it had held for eons, now converted into a straight-line exit velocity. 4. Theory B, the black hole pinball. The second theory, gaining traction in early 2026, suggests a more crowded origin. Astronomers believe J1249 plus 36 might have originated in a globular cluster, a dense beehive of hundreds of thousands of stars. At the center of many globular clusters lies an intermediate mass black hole. If J1249 plus 36 ventured too close to a binary pair of black holes, the resulting gravitational three-body interaction would act like a cosmic pinball flipper. The black holes would trade momentum, and the smallest object, in this case, our low-mass star, would be sacrificed and hurled out of the cluster and the galaxy at extreme speeds. 5. The primal composition, a fossil from the deep past. One of the most startling details revealed by Keck's near-infrared shell spectrograph. J1249 plus 36 is extremely metal-poor. In astronomy, metals are any elements heavier than hydrogen or helium. A metal-poor star is an ancient star, likely born during the very first few billion years of the universe's existence. This means the object isn't just a runaway, it is a fossil. It has been orbiting the Milky Way for perhaps 10 billion years, only to be suddenly evicted now. 6. The 2026 mystery. Why no tail? If J1249+36 was ejected by a supernova, it should be moving through a cloud of debris left over from its companion's explosion. However, JWST observations in February 2026 found no trace of an associated supernova remnant or a bow shock of gas. This lack of evidence has led some researchers to propose a third, even stranger possibility: dark matter interaction. Some fringe models suggest that if a star passes through a high-density clump of dark matter or an undetected primordial black hole, the gravitational drag could, in very specific circumstances, result in a slingshot effect. While speculative, the clean nature of J1249+36's exit, with no debris in its wake, is making this invisible kick theory a hot topic for debate. 7. The future. A wanderer between galaxies. As of today, J1249+36 is roughly 400 light-years away from Earth. In a few million years, it will cross the event horizon of our galaxy and enter the intergalactic void, the vast, empty space between the Milky Way and Andromeda. It will become an intergalactic rogue star. These objects are incredibly difficult to find because they have no home galaxy to illuminate them. By studying J1249+36 now, while it is still within our reach, astronomers are getting their first look at the population of ghost stars that likely haunt the voids between galaxies. 8. Why this matters. Testing the limits of gravity. The ejection of J1249+36 is more than just a space oddity. It is a vital test for our maps of galactic Massachusetts. To know if a star can escape, we have to know exactly how heavy the Milky Way is. If we find more objects like J1249+36 exiting the galaxy, it might suggest that the Milky Way is lighter than we previously thought, or that the dark matter halo surrounding our galaxy isn't as sticky as our models predict. J1249+36 is effectively a test particle that is probing the invisible boundaries of our galactic home. 9. The rogue planet connection. Finally, the discovery of this object has reignited interest in rogue planets. If a star can be ejected with such ease, how many millions of Earth-sized planets have been kicked into the void? Estimates in 2026 suggest there may be more rogue planets in the Milky Way than there are stars. J1249+36 is the big brother to these lonely worlds, proving that the galaxy is a violent, chaotic place where home is never a permanent guarantee. Conclusion: an outcast with a story. J1249+36 is a silent witness to a cosmic catastrophe. Whether it was the victim of a supernova betrayal or a victim of black hole bullying, it is now on a journey that no human will ever follow. It is leaving behind the warmth of the spiral arms for the eternal cold of the intergalactic dark. As Adam Burgasser, a lead researcher on the project, noted, "This star has seen things we can only dream of. It has survived a violence that would have vaporized our solar system, and now it is headed for a solitude that is almost impossible to comprehend."
Thanks for watching. If you enjoyed this journey through the cosmos, hit like, subscribe, and tap the bell. And when you're ready for your next space mystery, click the video right here.